Hello everyone, my name is Pedro Alves and I'm a math student. This is my Project-MEFT video. Maybe the title was not so explicit, but basically my dissertation consists on the assessment on how micromagnetic sensors employing magnetoresistance effect would behave in the harsh environment of space, and try to understand if it would be possible to use this type of sensors in future space missions, like for example near Earth, Moon, Mars, or even Jupiter. Magnetoresistance effect, in simple words, is the change of the electrical resistance of a magnetic material due to the application of a magnetic field. So, if a material presents this behavior, basically it can be used like a magnetic sensor, since, for a specific range, we may have a linear relation between the resistance and the magnetic field. This effect was discovered in 1856 by William Thomson, mostly known as Lord Kelvin. Also, in 2007, Albert Firth and Peter Grunberg were awarded with the Nobel Prize by the discovery of an unusual magnetoresistance, the so-called giant magnetoresistance. Since then, this phenomenon has allowed big advances, mainly in information and data storage technologies. The sensors employing this mechanism are also well known for their reduced dimensions, in the order of the microscale. Well, with all this talk about miniaturization of spacecrafts with the goal of turning missions more viable, also the instruments responsible for investigating magnetic fields are starting to feel this trend. Nowadays, current missions like Juno, Maven and the future JUICE are still employing bulky devices designed to measure magnetic fields, called flux gates, which can have about more or less 1 kilogram. Typically, each of spacecraft uses 2 of these plus another device to do the recalibration of the flux gates. So, now imagine how much wouldn't be nice instead of just having 2 flux gates have a lot of components, maybe tens or hundreds, doing the same function but with a total mass of less than 100 grams. Because it's not as simple as that. We cannot arrive to the lab and start doing lithographies, etchings, and physical vapor depositions in order to have a magnetic sensor and send it to space just like that. At least 2 fundamental points must be investigated. First, magnetoresistive sensors are still not optimized enough in a way to substitute the current technology used in space missions. And second, there are still a very few proofs about their radiation tolerance, in a way to know if they would survive or not if kicked by a cosmic ray. This is why more assessment in these 2 directions is needed. So, basically, this is what I am proposing to do: fabricate MR sensors and characterize them at INESC-MN, and then, with some help from LEAP and possibly from CTN, try to find out if this type of sensors has the potential to be applied for space, through the study of their response after being submitted to some radiation dose levels. With this, I conclude my brief thesis introduction. If you have any question, feel free to contact me by writing to this address. So, I hope to see you all in my master thesis presentation.